Go ahead, Dick.
Let me share my screen here and we'll get started. Thank you all for coming. And today we're going to talk about a little bit of refrigeration and things that are part of the cars that we see today. Council Lab has 4 air conditioning trainers, system trainers, and we talked about the newest one a while back when we talked about internal heat exchangers and superheat subcool. But we have one with an orifice tube, one with a TXV, one with an H block that all use 134A, and then our newest one uses 1234yf with an H block and an internal heat exchanger. What kind of refrigerants are we working with today? These are all refrigerants that you may see in a system on a car or truck or vehicle. Yet, the message today is having an identifier is an absolute necessity if you work on air conditioning systems. And we'll talk a little bit more about that later on. What's driving all of the changes for refrigerants? Of course, the government is, and they're trying to move towards more environmentally friendly refrigerants. And the newest buzz term is global warming potential, whereas they actually measure the ability of a gas to store energy or heat in the atmosphere, and they assign a number to that gas. And so refrigerants all have their GWP rating, and you see that R12 or CFC12 chlorofluorohydrocarbon or chlorofluorocarbon is 10,900. If you look at what we're using currently before the 1234, the 134A was 1430. That's still pretty high. And now 152, which we'll talk about today, is 124. And the current trend in gas refrigeration will be 1234yf, which has a GWP number of 4. And then R134A survives in the atmosphere for, depending on what you read, 10 to 15 years before breaking down. 1234yf takes 3 to 4 years to break down into harmless gases. So there's a huge advantage environmentally to use 1234. As Rick talked about CO2 yesterday, the government in 17 required that all vehicles have a fleet average of 250 grams per mile of CO2 or less. AC leak detection and reduction and efficiency improvements provide energy credits towards that number for OEs. And there's 2 types of credits available. One is called direct, and if you simply put 1234 in your car fleet, they'll give you 15.8 grams per mile of credit. Leak reduction, they'll give you up to 7.2. Indirect credits, if you just simply improve the efficiency, you'll get up to 5.7 grams per mile of credit. Now, Chrysler has probably the lowest CAFE rating, and they were the first ones, therefore, to use 1234yf. And that's why they did that. They needed the energy credits. Tesla makes some pretty good money on selling their energy credits to other OEs, which you can do because they're a ZEV or zero emission vehicle. 609 certification, in case you aren't aware of it, since 1990, any technician working for compensation needs to be 609 certified. You can become 609 certified by taking an open book test at Max. It's $20 for the study guide and the test. And I would suggest any of you that aren't 609 certified to get that way. January of 18, technicians now need 609 to purchase refrigerant, either 10 or 30 or anything other than 2 pounds or less. DIYers can still purchase 2 pounds or less in smaller cans without 609. 2 cans from January of 18 must have a self-sealing type of valve, no more puncture it and let it out into the atmosphere. Is it being enforced? Some states are very actively enforcing this 609 certification, Michigan being one of them. This is a 609 certification that you get when you successfully pass the test. You can take it as many times as you need to pass. I would consider joining the MAX organization. It's $140 a year for an educator or school. You get access to tons of information, and there's the website. I would strongly encourage you to join MAX if you haven't already. So what does the future hold? We're going to continue to drive towards more environmentally friendly refrigerant, and of course the cost will be higher until it stabilizes. 1234yf will become the refrigerant of choice for OEMs. 134A will soon become super expensive, in my opinion, to drive the phase-out program. Just like 12, you remember 12 went from 99 cents or less a can to mega money. In 2015, EPA told OEMs to start switching to 1234yf. 50% of the vehicles were estimated to be using it by 17. 19 model year, the majority of vehicles are using 1234yf, and visit MAX for the actual list. EPA mandated that no 2021 vehicle car sold in the US could have 134A refrigerant. This was immediately appealed by the manufacturers of refrigerant, and now the appeal evidently is either pending or has been won, and there is no current mandate saying you must have 1234yf in your cars, except for the advantage of energy credits. So what is this stuff anyway? If you're a chemist, it's hydrofluoroolefin, 1234yf. It's made by two companies, Honeywell, which calls Solstice, and DuPont, which calls Opteon. It has similar operating characteristics and pressures to 134A. It's considered to be mildly flammable and corrosive, and when burned, it changes to hydrogen fluoride. Who's using it? Well, here is a partial list of all the OEMs currently using 1234yf, and probably more importantly, who isn't using it. It is the refrigerant of choice today. The good news is it's very similar in operating and chemistry characteristics to 134A. You can see here that the properties are very similar. The only difference, major difference, is it has a much lower GWP number and mild flammability, which we'll talk about in a little bit. There's a lot of misinformation about 1234yf compared to 134A. As you know, Mercedes filed some lawsuits and had a program to state that 1234yf was super flammable. They did videos. They spent a lot of money protesting this to try to change the law. They lost. They now have cars with 1234yf systems, but DuPont immediately went to war with them and did some comparisons. You see that 1234yf takes 5,000 times more energy to ignite than these common gases down here. And somebody else did some studies about all of the fluids under the hood: engine oil, power steering fluid, brake fluid, antifreeze, even windshield washer fluid will burn before 1234yf will. So Mercedes lost. They have two systems out now. We'll talk about it a little bit later. So here's the new label you'll see under the hood of a car that has 1234yf. It has the statement of refrigerant, what type of oil is used. This is the SAE standards apply to that system. The new evaporator standard, the J2842, which we'll talk about, applies. This one is 2845 for technician training. This is the refrigerant amount, which normally is now listed in kilograms. You'll have to change it to pounds and ounces if you wish, but many machines are already calibrated for kilograms. This is the 609 certification, and of course a flammable signal. So this is the label that you'll see under the car. How much does this stuff cost? Well, in February of this year, I did a price check at my AutoZone. 10 pounds would cost me $600. That's $3.75 an ounce. My Chrysler dealer told me they charge $12.02 per ounce, and a typical job running out of a Chrysler dealer is 16 to 25 ounces, so that's almost $200 to $300 just for the refrigerant plus parts and labor. $1,000 AC ticket is not uncommon today. especially if the car has been in an accident. Other refrigerants, 744. CO2 is not a new refrigerant. It's been used in an industry for years. But now we're starting to see it possibly under cars and trucks. The problem is its pressures are 7 to 10 times higher. Normal high side is 3 to 600 pounds, or low side is 3 to 6, high side is 1800 or more. That means more robust lines, compressors, all of the things involved with high pressure. And another problem is what happens if the evaporator leaks CO2? Well, you can become toxic inside the car, especially if you have a carload of people that they're expelling CO2 also. So there's a website dedicated for CO2 refrigeration if you want to get more information. So what they've done is designed the system to be a split system. So you have an under the hood system and an under the car system or inside the car. And they basically use a chiller that the refrigerant cools a non-toxic, usually antifreeze and water with a circulating pump to keep the passengers inside cool. Therefore, you don't have the leak inside the car of possible CO2. Problem, though, is how do you find a leak in a system where gas naturally occurs in the atmosphere? Many people are considering putting an odorant or detectable gas like they do with methane, which is natural gas. They put mercaptan in it to make it smell like sulfur. If a leak were to occur in the evaporator, the CO2 levels will become toxic, so that's why we have a split system. Another new refrigerant, to us in cars anyway, is called HFC 152A, also called the duster refrigerant. It's very similar to 134A in characteristics. It's cheaper. Some countries are considering adopting it. U.S. companies are looking into this, but no fleet decision has been made yet. It's very flammable, however. The system would also have to address occupant and technician safety. And it would be also a secondary system like typically is drawn here. This is not a real car. This is a rendering of what a 152A system would look like. You've seen this refrigerant before, and you may even have used it. It's called duster. It's what everyone uses to clean the keyboards on your computers and electronic stuff. That is 152A refrigerant and is very flammable. It is being considered because of its cost and its EPA potential for car refrigerants. My own personal, not proven to anybody, predictions are with the cost of 1234yf so high, what will happen? Well, as the vehicles come out of warranty, I suspect there'll be some that get filled with 134A. Refrigerant identification will become more critical than it is today. You must now have an identifier. The cost of 134A will significantly increase to continue to drive up the cost, so we phase in 1234. Customers' cars will have lots of miracles in a can already in the system before they come to you. Aftermarket cheating will become more common, and unless something changes, my own prediction is the enforcement of laws will remain weak. Somebody's going to get burned, but overall, we have to increase the enforcement to keep these standards in force. What's showing up in refrigerant identifiers, even in some vehicles? 410, which is the replacement for R22, which is a household refrigerant. I've seen that in a lot of cars. Propane, butane, R152A, those appear as hydrocarbons on an identifier. You must always identify the refrigerant before contaminating your equipment. This is a Neutronics refrigerant identifier that was hooked up to a car. You see that it has 82% 134A, almost 10% 12, 2% R22, and 5.8% of hydrocarbons. This is a very contaminated system. The future, cars are now being designed with heat pumps. They're trying to, again, come up with a way of keeping you cool with other innovative systems. Nissan has a functioning heat pump system, cabin heater now. It's used in their Leaf EV vehicle. There's also systems using the Peltier effect and magnetocaloric systems. I mean, our big PowerPoint that I have shows all those systems. AC compressors will be moving towards electric drive instead of belt drive. Variable displacement compressors are much more common today. Current thinking in CO2 systems will not be common in vehicles due to the high pressures and sensitivity to small leaks, although Mercedes and I think BMW both have a R744 system. There's research done always on new systems. Up and coming changes, refrigerant capacities are going down. A 2018 Cruise is only 16 ounces. Accurate charge levels are now supercritical. Much less oil is being used in systems today. Compressors have centrifugal oil separators to keep oil in the reservoir and not circulate in the system. Topping off refrigerant in a system should never, ever be done today. What does a typical DIYer have to try to fix their car before they bring it to you? This stuff is called a universal refrigerant. You notice it says replaces HFC 134A and other CFC 12 substitutes. This is pure hydrocarbons. It's sold under those names. I've been told that you can still buy it in Canada and the US. There's lawsuits against people that are selling it. Don't do it. There's Duracool, which is another universal refrigerant. Do not use this product. It is bad stuff. Hydrocarbon-based refrigerant. And you go into a store and say, my air conditioning doesn't work, they're probably going to sell you one of these miracles in a can, and all of them contain sealers in it. And sealers will plug up your system more often than not. This is a GM accumulator taken apart. The desiccant bag is all plugged up. It's green because of the dye that was in the system. Don't use it. Nutronics sells a sealant detector kit, which I would suggest you consider buying. It will detect the presence of sealer before you hook it up to your machine and prevent contamination. There are also many things that you can install prior to your recycling machine to protect it from these contaminants, and it removes the dye, lubricants, and contaminants before. Many upper level machines already have these systems built into them. Make sure yours does. If not, get one. AirSep has one that can be installed prior to the recycling machine to get rid of this junk before it goes into your machine. Remember, a sealer thinks as a whole is if something they want to fix, and the orifices in your recycling machine can become plugged with sealers. There are DIY charging kits. They're also now available for 1234yf. Here's one from Honeywell, $90 for 2 8-ounce cans and a hose on eBay in February of this year. Here's one. Look at this. Where do you think that came from? I would be a little hesitant to use that product. I can't even spell gauge properly. Can taps are available for 1234. The threads on a 1234 small can are 1/2 inch Acme left hand. So you cannot cross threads the can taps on 134As. Refrigerant oils. Of course, the old oil that we're all used to was R12 mineral oil. Never, ever have that in your shop. Get rid of it if you do. It's not compatible with any oil that we use today. PEG oil. Most R134A systems and some 1234 systems use PEG. It can vary greatly in viscosity. You want to make sure that you follow OEM recommendations on the type of PEG oil that you have, and especially the viscosity. There is no universal oil. POE or ester oil is some 134A systems, some R12 retrofit kits, and some 1234yf hybrids use ester oils. Chrysler has a PEG oil, ND12, that's for 1234. It's backwards compatible to 134A, but you can't go the other way. Bottom line here is always follow manufacturer-specific vehicle service information with oil. There is no universal oil. Never assume. You can get yourself into a lot of trouble by using the wrong oil and the wrong capacity of oil. Most hybrid EV compressors use POE oils, and most non-hybrid use PEG. The electric hybrid compressor that are electrically driven with high voltage takes a special non-conductive kind of oil. That's very important, and that's one of the reasons that we've changed some of the standards on SAE. If you put the wrong oil in a hybrid car with electric driven compressor with 288 volts, you can go into tennis shoe mode real fast, because when you push start, that system goes into an insulation test, and if it detects that it's got conductive oil in the compressor, it will not let that vehicle start, and you're now got a problem. The new J standard on recycling machines says you can no longer use the machine to inject oil. If you put oil into a system, it must be done manually with one of these various types of injectors. The reason for that primarily is the non-conductive concern with hybrid compressors. So you can't inject oil on your machine anymore. Compressors. ConsulLab has a full line of cutaway compressors that you can use for your instruction purposes. Compressors now have oil trapping systems in them. Oil volume is 90% less today than 20 years ago. The oil now stays in the compressor and not the system. This fact will have a huge impact on how dye leak detection works. Dye is currently circulated by the refrigerant oil and not the refrigerant. So how do we get around that? Many in the industry are going to sniffers now for leak detection. Refrigerant capacities have dropped about 50% due to new efficiencies in system design. Variable displacement compressors are becoming very common. They can also be clutchless, no clutch in the compressor, which means it runs all the time. There is a compact, electronically pulse width modulated compressor, and it's commanded by the BCM, or the heating control module. It has a duty cycle solenoid that can control the output of the compressor. You want to be careful that you know these things, because a non-functioning pulse width modulated circuit can mask, it can show up as low charge because your pressures are low, and you start dumping refrigerant in there, and you're going to overcharge the system without dealing with the problem. This is very common in the industry with technicians that don't understand variable displacement compressors. The clutchless, or run all the time, compressors have some type of protection device, either that will allow the pulley to shear off from the compressor crankshaft in case there's a lockup or something happens. Electric and EV compressors that are driven with high voltage or orange cables. The typical high pressure, we have an AC brushless motor that can have 2 or 3 high voltage cables going to it. The output of the compressor is controlled by varying the frequency of the motor, just like we do in some fuel pumps, and not the voltage. Honda has kind of a unique one that does both electric and a belt driven. And the kind of the high voltage cables are buried behind it. So if you see a belt on a compressor, don't assume it's not high voltage. So here's the split Honda compressor. The front half is driven by a belt when you're going down the road. The back half, when you're in stealth mode or hybrid mode, can be driven by the motor. It's the same compressor, but it's divided into 2 halves. The new 2842 SAE standard on evaporators basically says if you take the evaporator out, you must put it back in. If you go out because it's damaged, you cannot go to a recycling yard and get one off a used car. It must be new. Why? Because of the potential liability concerns with the flammability aspect of 1234yf. The evaporator has made it more robust, thicker. It's got some anti-corrosion coatings inside of it. And there's a change in model years, where an evaporator from a 134A system may look the same as a 1234, but that's why that J standard is in there. You must only use new when replacing the evaporator. You can put your other one back in if you had to take it out to get at something else, but if it's damaged, you must replace it with a new one, not a used one. There's the label on the evaporator housing. Basically states, we've told you that this standard is in place, therefore we expect you to follow it. Another new component that we're seeing is subcooling condensers. It's another efficiency that gives more GWP credits. What it is, it's something that ensures that we have full liquid with no vapor exiting the condenser. It also can be a second condenser. Many of them have a filter installed with them. GM does that quite often. So here's a cutaway showing that we have gas coming in from the compressor to the condenser, and then we block it. It has to go all the way through. And then over here on the far left, you will see this modulator, which is like a secondary or assist condenser, just to make sure we wring all of the vapor out of that refrigerant and we have full liquid. This is what it looks like in reality. This is off of a Hyundai. It can be called a dual condenser, secondary condenser, sub-condenser, or modulator. And 134A systems also use subcooling condensers. Other relatively new stuff, stretch to fit belts. You can identify them by the lack of a tensioner. They make special tools to put them on. I've heard of technicians using screwdrivers and socket extensions, whatever the trick is. You want to be careful of these because you can get hurt putting these on. GM also in many cars in the 2000s up have filters right from the factory put in the system. You want to make sure that you know that that filter is in there, and so you don't put a secondary filter in if you had a compressor failure. Normally, this is a muffler, and sometimes the muffler can be having a filter inside also. Bottom line is always check OE specific service information before you start adding things to these systems. It's very important that you know the system that you're working on. And of course, I don't know how many hundreds and thousands of dollars have been spent because the cabin filter was plugged up and they were replacing compressors and evaporators and condensers. Many people don't even know that a cabin filter exists. And I can't overly stress the importance of making sure that this cabin filter gets replaced on a periodic, regular basis. And I know you probably could all tell us stories about the worst looking cabin filter you pulled out of a car. Many customers don't even know they exist. This is the service ports for 1234yf. Most cars do not use the red and blue anymore. They are different diameters, so you really can't connect your 134A stuff to it. Therefore, you need a new machine. There's the latest and greatest from Robin Air. Its current price is around $6,500, and it does meet the J2843 standard. And by the way, the standards means that you can't inject oil, as I said before. It also has to have an integral identifier. When it first came out, they realized that some of the machines did not have an identifier, or they weren't able to receive a signal from a handheld identifier. So they realized that that was wrong, and as those machines are no longer able to be manufactured. And now when you buy a 2843 machine, it's either going to have a built-in identifier or it can accept a USB connection to a remote identifier and will stop the whole system. You will not be able to evacuate if it detects a contamination of refrigerant. That's the most important part of the new machines. Of course, now adapters are available. You can use your 134A gauges on 1234yf system. Again, I'm not condoning that. I'm not suggesting it, but adapters are available. Here's a machine that is much lower in price. It says it's 2843 compliant, and the only way they can sell it for that price is to have a cable that they say will work with a remote identifier, and I'm very suspicious about that. Here's an article that you can access from SAE that explains a lot more about J2843 standards, and you should become familiar with it if you are looking to buy a machine. An identifier must be built in, or the machine must be equipped with a USB port to accept an ID signal from an identifier connected to the vehicle being serviced. If the signal does not indicate a sufficiently pure refrigerant charge, the machine will not enable recovery and block further action. Many systems, Chrysler is now installing dye right in the system from the factory. Why? To increase that energy credit potential. Good news is the pressures and temperatures of the two refrigerants are very, very similar. Here's a chart that I use. There's 134A at a 32 evaporator temperature, 28 psi. 1234yf is only 3 pounds higher. They run pretty much a mirror image of each other. Here's R744 at 513 at 35 degrees evaporator temperature. Propane, which you also will see, is 40 psi, and the 152A is 45 psi. So they're all relatively in the ballpark. Leak detectors. Here's one made by Mastercool that is J2913 and 2791, which means it will accurately sniff 134A and 1234yf. It sells for $163,842. Matco makes one. Sells for $382.95. Both compliant. You decide. Many people say you can't sniff 1234yf. It's because they tried to use a 134A sniffer on it, and you cannot. So make sure that you get one with J2913 for 1234yf and 2791 with 134A. The importance of proper charge, never top off. Look at the specifications for these cars. Very, I mean, you remember in the 70s when we had GM cars with 5 pounds of refrigerant? Refrigerant capacities are much less than on previous vehicles. Always check specs. One of the most common causes of problems today is the system either has too much or too little refrigerant or excess oil. Remember that exact charge is critical, and also having the wrong amounts of oil because it displaces the refrigerant volume. With new systems, it's extremely critical to properly evacuate the system for 30 minutes to 1 hour. And with small capacity systems, leaving a very small amount of air and moisture can cause serious performance problems. After evacuation, always make sure that you have this thing setting on a leak test for 30 to 45 minutes. The biggest complaint of technicians of the new machines, it takes too long, up to 2 hours, because it's already pre-programmed to do these things for 1 hour each. They want to make sure that that system is properly sealed. And with that, I have finished. I hope that I haven't gone terribly fast for you, but I'll be opening up this for questions and comments. If anybody has anything they'd like to say, you can unmute yourself and we can have a discussion.
Well, I'm going to just quickly stop the recording, but everybody can jump in and ask whatever questions they have.